Hello to the University of Sussex's Open Day in Engineering. My name is Harri Koivisto and I'm a teaching fellow in mechanical engineering. And today here in the studio we also have my colleague Mark Patok-Brown joining you guys. And since this is a live presentation, there's a number at the bottom of the screen where you can text us or WhatsApp questions. We both love questions, so please send us as many questions as you can. And I think we are quite good at answering questions as well, since both Mark and myself, we are actually old undergraduates. We've done our degrees at the University of Sussex before we became academics here. So, starting with our presentation, we thought that it would be good to let you know what engineering is actually all about. And to quote here one of my favorite scientists, physicist Richard Feynman, he wrote a wonderful algorithm for solving problems. He said step 1 is to write down the problem, step 2 is to think very, very hard, and then step 3 is to write down the solution to that problem. And I think that's very applicable to physicists. The only difference with engineers is that you also have to do something in terms of creating a machine, a process, a new system. So engineering in some ways is actually, I think, a bit more challenging. You have to take the fundamental blocks of mathematics and sciences and use that as your toolbox, and then think about the problem, or sometimes even come up with a brand new problem that you want to solve. And then ultimately at the very top you have to create a solution to that problem. And that's the really fun bit with engineering that I've always been fascinated with, creating and thinking about problems. And I think not any problem that you have, it'll have more than one solution to it. So there's a lot of nice creativity with engineering as well that I very much enjoy. And I shall hand you now to Mark, who will be talking a little bit more about our core values at the university.
Thank you, Harry. And hello to everyone out there in the ether. I wanted to talk to you today about engineering at Sussex, and I thought I'd start with our 3 core messages, starting with accessibility. We're an accessible general engineering department, and so we give you a broad foundation which to build on, not just for your degree and your career, but the whole life learning process. We have a focus on sustainable future technologies to give you the experiences and the skill sets ready to meet the challenges facing the modern world. And employability. Engineers rarely work alone. You need to work within an organisation, in a team, and employability is a really important part of that. And actually we're going to have a slide on that later with Harry. Inside of our core message, we have, thank you Harry, we have the core values of the University of Sussex: integrity, inclusion, kindness, collaboration, and courage to make a positive impact in the world. Back to you, Harry.
Thank you very much, Mark. Next, we would like to talk to you a little bit about our degrees. What kind of degrees do we offer? They can be divided into these main branches. So we have automotive engineering branch, we have the electrical and electronic branch, which also includes communication, things like 5G networks, mechanical engineering, and then robotics. And the robotics is our recent addition, and it can also be joined together with the electrical and electronic engineering, or you can join it together with the mechanical engineering degree, depending on which area you sort of want to specialize a little bit more in. And also very nicely, since employment is really important, and it's important that we're teaching you skills that you can actually use out there in the real world after you graduate with us, we have the Year in Industry scheme. So in any of these degrees, you can go for 1 year out into the industry and gain some really good perspective on what it is to be out there in the real world working as an engineer. Also, all of these degrees come in various different variants, so you can do a foundation year. So for example, if you don't have quite the grades that you need to enter directly to our year 1, you can do a foundation year and then enter to our year 1. Or if you're just sort of thinking of changing your direction, so maybe you were thinking of studying something else before and then thought, actually I want to do engineering. So our foundation year is an ideal chance for you to do that change. And also all of these degrees go together with our MEng degrees, so you can do these degrees all the way up to the master's level, so a 4-year study, or 5 years if you do the year in industry in between. And now I'll hand you to Mark, who will be talking a little bit more about the content of all of these degrees that we offer.
Harry, before I start, I've had a couple of questions come in, so I'm just going to answer those first. First one is, how many students do you have each year on the MEng degree? We have obviously a different number each year, but we are averaging probably around 100 or so. Harry, am I about right?
I would think so. About 100 is
a good number. Yeah. So we're a smallish department, but we really like that. It means we get a real chance to get to know you, get to see you grow, and it's fantastic to share a glass of champagne, Prosecco, or orange juice on graduation day with you, knowing that we've been there seeing you from first year, second year, third year, fourth year, maybe even foundation year as well. So that's really key. So we really like the ratio of faculty to students. I also have another question. Is the student accommodation close to the classes and labs? Actually, Harry, I think you'll answer that one best.
Yes, thank you, Mark. So, since I've done my undergraduate here, I used to live on the East Slope buildings, which were very old buildings, and they've all been taken out now and replaced with a very nice set of buildings. But I remember as an undergraduate on my first year studying mechanical engineering, I would wake up sort of 10 minutes before the lecture started, grab a pot of yogurt and a spoon, and then walk out of the door and walk across the field to the lecture hall. And I would eat the yogurt on the way and still make it on time for my 9 a.m. lecture in the morning. So the accommodation on campus that you have, I think the furthest is Northfields at the very back end of the campus. And from there to walk to our normal lecturing areas and lab areas, it would probably take you about 10 minutes to walk across on the campus. There's also good disabled access with everything, and then we have the local buses operating on campus. So I believe it is free to take a bus anywhere from campus to another point on campus if you, for whatever reason, don't want to walk. Maybe it's raining a lot. There are some accommodation also in town in the city of Brighton and Hove, so those would be about a 9-minute train ride to the Falmer train station that's next to us, and then from there it would be another 5-minute walk to get to the lecturing areas and the academic buildings.
Thank you, Harry. Okay, let's have a look at the course content. So if I went through the exhaustive list, all the modules that we have, we'd be here till next September. So I thought we'd just give you a rundown of the subject areas for each of our courses. We start with the blue bar at the top. So these are common to all of our courses. So we have managerial, professional skills, mathematics to build those core muscles of engineering. We have materials and manufacturing. You always want to ask the question, what do I make it out of and how do I make it? Programming, really important for the modern engineer, and frankly it's going to be really important in future careers across any sector. So programs are really core and important skill to develop. And thermodynamics, we always have a lot of heat, power, energy. We need to know how things in the world work. If we look at our electrical and electronic degrees in purple, we've got analog and digital circuits. Analog's not out of the count yet, it's still around and still really important. We have communication, 5G and beyond, electrical power, because we want to know how to power these things, and also bigger power systems like the grid. Control, everyone loves a bit of positive feedback, and embedded systems, really important for anything like Internet of Things, all these little smart gadgets and devices that you have all around your home. If we look at the middle in lighter green, we've got our mechanical kind of core areas. We've got CAD, computer-aided design, technical drawing and simulation, whether that be fluid or structural. We have fluid mechanics, anything to do with flow or fluids. Design, because we want to be able to design machines and systems, so that's a big part of it. Heat transfer, really important for anything to do with sustainability, minimizing energy use. We don't want it bleeding out everywhere, so we have heat transfer, great for insulation, all those kinds of things. Mechanics, not the getting your hands dirty in a car engine bay, but kinematics and dynamics and statics and looking at forces and moments and those kind of things there. And also power cycles, so anything to do with steam cycles and gas turbines and Otto and diesel and all the kind of the power cycles that you have all over the modern world. If you're looking at robotics, then mechatronics, autonomous vehicles, robot design, all very important for robots. With mechatronics, for instance, you'd have access to our small-scale automated industrial manufacturing platform there, autonomous vehicles as well. We're also going to see that's going to be really big. And if you were to take the automotive strand in orange, then we'd have vehicles, automotive vehicle technology, very important, engines, and then also looking forward, drive systems. We're looking towards electric vehicles, those kind of things there. Harry, I believe that's back to you.
Yep. So all these things that Mark was talking about, these sort of core modules, and of course we have a lot more of them, so those were just the sort of main areas of engineering that you would look into in each of the degrees. But also on top of all of that, what we have is employability skills embedded in all of these modules. So in this slide you see some of those kinds of skills that we train you with, but just to give you some examples, we do a lot of presentations with our students, so students learn about presentation skills throughout their 3 or 4 years that they're here at Sussex with us. They learn about working in a group, so we have some tasks that are for group work, and that's really, really important to learn to know how to work with other engineers. It's quite challenging actually often, and that's what makes a good engineer, is somebody who can actually coordinate and manage a group of other engineers from interdisciplinary fields. And within our modules we give you the chance to sort of practice that throughout your degrees. And things of that sort. We also have academic advisors at the university, so when you arrive here you will be joined together with a member of staff, and they will be with you effectively throughout your studies. On your first year of studies you'll meet them on a fortnightly basis to discuss all sorts of things related to your learning. And here just to point out a little picture of a very exemplary group work in action. So here we have our wind turbine powered car team. So every year they build a car that is purely powered by a wind turbine that's on top of it. Hardly a sustainable, well, hardly a realistic way of traveling from point A to point B, but embedded in that project is a lot of fluid dynamic skills, control skills for electronics, controlling that turbine on the top and getting the power out of it, mechanical engineering skills and design skills, you name it. There's a lot of things incorporated in this project. And of course, it's a group of MN students, fourth year students, working on that car together for a whole year. And then we take it every summer to a sustainable energy race in Holland, and we compete against other universities with that car. So it's a lot of good fun to be involved in. And back to you, Mark.
Harry? Before I start my side again, if more questions have come in, so I'm going to go through these. Can I do a placement? We've already mentioned the year in industry, typically after the second year and for the third year, but there's also other opportunities for placements. Quite a few of our students go on summer placements, so working in a company for say 6-8 weeks. And we also have the Career Centre on campus that can help you in terms of building a CV, applying for these positions, interview techniques, those kind of things there. So yes, there are plenty of opportunities to do placements. Sizes are the classes. So another kind of tricky question, depending on what kind of class it is. If it's say a lecture and it's a common core module across all of the strands, then you could have maybe 200 students in a lecture hall, because that's all the mechanical, electrical, automotive, robotics. You could then have workshop sessions that might be closer to 30 students, and then lab sessions that may be more like 10 to 20. Or academic advisee sessions where you might just have 4. And, not time for that question, but Harry, please.
All right. I think, actually, Mark.
Sorry, Harry.
It's all right.
Just to say, this is a great time to be an engineer. And actually, graduate staff salaries are above 25k a year, so that's really good. Lots of people employed, 5.7 million. And even if we can't take into account all of this, all of the engineering graduates that are still there, we still have 20,000 UK annual shortfall of engineering graduates. So with a good degree and your good employability core competencies, there's plenty of opportunity out there for you. And
Okay, now it's back to me. As our final slide, we just wanted to show you a bit about our research groups as well. What kind of research do we get involved in at the university? And from a student perspective, you might ask, well, how is this relevant to you? But these are the kinds of groups where we have staff who are worth leading in these areas. So this kind of content, it feeds into the modules that you'll be taught by the experts. So I won't name all of these groups, but we have a wide range of groups in the electronic side, on the dynamics and control side, vehicle research, and I do have to put the thermofluids mechanics research group, which is the group that Mark and I are part of. That's a group where we develop stuff for jet engines and energy production. So that's the group that we are working in. Now, that's the end of our presentation. Thank you very much for listening. And if you didn't get your question answered, then let me just remind you that in your invitation packages, you should have also received an invitation for a Zoom session where our colleagues will be answering your questions. And this is taking place between 12 o'clock and 2 o'clock. Thank you very much for being a wonderful audience. I was a bit afraid that we wouldn't get that many questions, but I was so very pleased that we could at least communicate with you like this from our studio. And I really, really hope that we see you face to face in the nearby future and we can have a chat about engineering in more detail. Thank you very much for listening.
Thank you.